Hi there, this is Penelope, and this is a short video for MG5004 DE5418 on possible test questions, and this one is finding a second derivative where the function is expressed parametrically. Here's an example. We'll do two examples. The first one gives you y and x in terms of t, and you need to find dy by dx. Okay, so dy by dx, just using the formula, would be dy by dt over dx by dt. And the second derivative, we may as well write it now, is equal to the derivative of the derivative divided by dx by dt. Okay, so y is given to you, so we can find dy by dt is equal to negative 6 sine 2t, and dx by dt is 2 cos t. So putting those together then, dy by dx would be negative 6 sine 2t over dx by dt. And if we simplify that, we can rearrange the top line using double angle formulas to being 2 sine t cos t. That shouldn't be a 2. Like that, then we can cancel, and all we're left with is negative 6 sine t, because the 2's cancel as well. Okay, finding the second derivative then, this would be equal to the derivative of what we've just found divided by 2 cos t. And the derivative of negative 6 sine t would be negative 6 cos t over 2 cos t, which is straight negative 3. The second example is where we've got a little bit more complicated function, but the process is exactly the same, and the fact that it traces out a cycloid doesn't really matter at all. So first up, we'd need to find dx by d theta, which I won't do all the steps, but it would be 4 times 1 minus cos theta, and dy by d theta, again I won't do all the steps, but it would be 4 sine theta. Okay, putting that together then, dy by dx is equal to dy by d theta, which is 4 sine theta over dx by d theta, and simplifying that, cancelling, and we have sine theta over 1 minus cos theta. To find the second derivative, the second derivative is the derivative with respect to theta of the first derivative over dx by d theta. Now we've found dx by d theta as being 4 times 1 minus cos theta. Now we have to find the derivative of what we've just found, and we would need to use the quotient rule for that on the top line, being careful, times cos theta minus the top times the derivative of the bottom, all over the bottom squared. This is just the top line I'm doing, and that's got to be over 4 times 1 minus cos theta. Doing a bit of simplification then, and jiggling around, expanding the brackets, and remembering that cos squared plus sine squared is equal to 1, we end up with cos theta minus 1, over 4 times 1 minus cos theta. And if I take a negative sign out of that, then I have 1 minus cos theta over 4 times, oh dear, I've lost a cube, that should be cubed, over 1 minus cos theta cubed, which I can simplify to negative 1 over 4 times 1 minus cos theta squared. Now at this stage I expect you to do the intermediate steps if you can't sing out, and I can offer the help that you need. But this is just all to get to here. We're just using trig identities, very basic trig identities.